Given f of s, we need to find the partial fraction expansion of f of s, and then use the Laplace transform tables to find our f of t. Now, our Laplace transform tables, we can look in the notes linked below the like button. You can check those out. These are notes for this. It has all of these three things that I've listed down here. We're going to use all three of these different things to actually compute this problem. So to start off, we are going to look at this right here. We can see our denominator is a complex number. And since it's a complex number, we're going to have to do a little bit something different to actually get this. So looking at this, what we can do is just some differential equation stuff. We are going to set this equal to an a over our first part, which is s plus 8, and then plus b over our next part, which is s plus 6 minus j10, and then we have plus b, and since it's a conjugate, right, and since it's an imaginary number, we're just going to have b with the conjugate symbol right here. So we're going to take the inverse or the opposite angle that we have here, and that'll make more sense in a second. So this will be over our s plus 6 plus j10. And so this is what we have here. Now we can use the Heaviside cover-up to find our a, b, and b star. So to find our a, I'm going to do this in green. We have a over our s plus 8, and it's equal to our entire equation, which is 10 s squared plus 40, and this is all over s plus 8. And instead of writing out the imaginary part right here, we can just write out the original part right here. So we're going to have s squared plus 12s plus 136. Now we can take this s plus 8 from both sides and just factor it out. And then we can look at this and we're going to plug in our s. And s is going to be whatever would have made this 0. So s in this case is equal to -8. So if we plug this into a calculator, we're going to get that our a is equal to 10. And then we can plug this back into here. So we found that our a is 10, and this is going to yield us a 10 over s plus 8. And now looking at this, we want to transform this into the Laplace transform to find our f of t. So the Laplace transform of this is going to be this. We have something that looks like this, and we're going to change it to be like this. We have a 10 out front, because it's not up here in our equation. We are then going to have an e to the -8t. And then this is being multiplied by u of t. And so this is our first part done, and we can plug it into here. We have 10e to the -8t. Then we have plus. Now we have to look at our part b, which has the complex number in it. And so in our part b, it's going to be b over, and this is over whatever we have as b. So in this case, it's s plus 6 minus j10. And this is equal to our entire equation. So again, 10 s squared plus 40. This time though, since we are actually dealing with this specifically, we need to write out the entire bottom. So we're going to have s plus 8, and then we're going to have s plus 6 minus j10. And then we're also going to have s plus 6 plus j10. Now, looking at this, we can factor out this with this. So those are no longer going to be an issue. And then we can plug in where s, if it's equal to a -6 plus j10, because that would have made this 0. And now, if we plug this in, we are going to get that, and I'll just draw a line so we don't confuse these, that b is equal to a 10, and then we have a 36 minus a j120 minus 100, and that's if we were to plug this in to here and then combine it, plus 40. And now this is all going to be divided by our bottom part. In our bottom part, we're just going to have a 2 plus j10, and then we're going to have a times j20. Now, in here, we're going to divide everything by 10, and so that is going to get rid of that 10, and we can combine like terms and simplify. This will give us a b is equal to a -24 minus j120, and this is over a -20 plus j4. Now, we can take everything our numerator and our denominator, and we can multiply it by a negative 1 over 4, negative 1 over 4. And then if we do this, we're going to get that our b is equal to a 6 plus j 30, and this is divided by a 5 minus j. And so to divide something like this, we're going to need to convert it into the polar form instead of the rectangular form, which is in right now. And that's what we would use these equations for. If we were to do this, plugging this into a calculator and all that, and then we would get a b is equal to 31 over 79, and this is divided by approximately 5.1 over negative 11. Remember, you want to divide the real numbers and then subtract the denominator angle from our numerator angle. And this is going to give us that our b is equal to 6 with an angle of 90 degrees. So when we plug this in here, we're going to have 6 with an angle of 90 degrees, and the conjugate of this is going to be 6 with an angle of negative 90 degrees. Now this is where this part comes in. We need to find this right here. All of this is the time domain, and we're plugging it into here. And so we know that our k is this value right here, and if we look right here, it's going to be the 6. So we have 2 times k, which will give us a 12, and then we have a negative alpha t. Well, this alpha is this part, and our beta is this part. So our alpha is going to be 6, and our beta is going to just be 10. And so in here, we are going to have a negative 6t. And then we have our cosine, we have our beta, which is 10, we have the t, plus our omega, or plus our angle, I'm sorry, and our angle here is 90 degrees. Now that we have this, that is our answer. So that is how you'd go about solving for this problem. You need to find the Laplace transform. We would use the table that's provided in the notes, again linked below the like button, wink wink, and then we would also use this, which is also in the notes linked below the like button. This is for when we have complex numbers, as we do here. Otherwise, we could just use the Heaviside cover-up and solve for each a, b, c, d, so on and so forth. So that's how you would look at this problem.